Welcome to How To. Today I will talk about how you can understand engineering and involve yourself in the industry. Today I'll be going over 7 points I believe are fundamentally important to understanding the field of engineering. First, the mindset, how to think like an engineer. Second, the philosophies, guidance when creating a product. Third, fields and different careers you can go into. Fourth, specific skills you need to succeed. Fifth, how you can get involved and where to start learning these skills. Sixth, working at a startup compared to a company. And seventh, the future of engineering. First, the mindset. Engineering is not just using technical skills to create a product, it involves a lot of brainstorming and mental work to come up with possible solutions as well. 2 ways to do this are problem solving and critical thinking. First, problem solving. From Wikipedia, problem solving is the process of achieving a goal by overcoming obstacles, a frequent part of most activities. Mentioned at the end of that quote, this is a skill that everyone has been developing from a young age. Overcoming problems is an everyday task, which means that you have been developing this skill for years. Critical thinking, described as the process of analyzing available facts, evidence, observations, and arguments to make a sound conclusion or informed choices, is meant to help you find the most effective solution for a problem. While these 2 skills sound different, they are best used in tandem. For example, if you were waltzing down the sidewalk, saw a puddle in your path, you could come up with many different solutions. 1. Walk straight through the puddle. 2. Jump over the puddle. 3. Walk around the puddle. 4. Wait for the puddle to evaporate. Or 5. Just walk the opposite direction. Critical thinking is what you use to determine what the best option is for the result you want. If you wanted to get somewhere as fast as possible, just walk straight through the puddle. If you want your shoes to stay clean, wait for it to evaporate. If you're exercising, then just go the opposite direction. All of those solutions work, but each of them have their own unique advantages. Next, we'll talk about engineering design philosophies. These are a set of principles that will help influence how you design and make a product. For example, make simple clever. This means that you need to make something that is easily understandable and usable, but is innovative and effective for its purpose. Here in the image, we can see a more literal philosophy. This image was taken from a NASA document. It starts with creating their systems, then moving to compartmentalization, where they divide the system into either subsystems or components, and then they do additional testing for each. This is a literal route that they take for developing well-made components while also making sure that they're safe. Next, we'll look at the fields of engineering. Now, you may only see 6 fields and wonder, hey, but where's biomedical engineering? Aren't there way more than this? There are, but most of these additional fields are a mix of these 6, with aerospace engineering being unique enough that it deserves a spot on this list. First, civil engineering. This discipline involves designing or building infrastructure, mainly for cities. An example of this is designing water runoff points and drainage spots for streets. It can also include making tools or designing mines for extracting natural resources. Second, mechanical engineering. This is the most broad type of engineering and is what a lot of engineers have a degree in, as it can be used for most careers. You'll be creating and improving products and components for many different things. Third, chemical engineering. Chemical engineering is using raw materials to make another material or product. This includes turning crude oil into things like gas and plastic, or designing chemical processes to create one of these new materials. This could be an up-and-coming field, especially with future demand for creating quantum computers. There could be a lot of demand for making new materials for cooling, especially with those costs being on the rise. Fourth, electrical engineering. This field is as simple as its name. You'll be using an understanding of electromagnetism and physics to create electrical components. This is also heavily associated with a lot of other fields, as almost everything requires some form of electrical component. Fifth, aerospace engineering. Here you'll be making flight and space vehicles. This is one of, if not the most complex field, as you need a deep understanding of physics, aerodynamics, and along with the skills to design advanced parts. This field has a lot of regulation because of the amount of people that fly in planes and the risk of flying spacecraft. For example, every plane and spacecraft needs to be perfect. These careers are typically making very small parts for these large machines. You'll most likely not be designing a rocket or even a whole piece of a vehicle yourself. Last but not least, computer or software and hardware engineering. This is either making computer components like graphics cards or designing software like operating systems. This will be one of the most popular fields in the next decade, as there will be more demand than ever for advanced computers, especially for AI and quantum computing. OpenAI already has a large stake in this market, and companies like Nvidia are certainly looking for more people. Next, I will go over some specific skills that I think you could learn to give you an edge over the others. We already went over problem solving and critical thinking and their importance, so we will start with CAD, or computer-aided design. This is the second most important thing to learn as an engineer, as making a product in modern times is made significantly easier by using CAD programs to create 3D and 2D models. CAD is making a visualization of a product with exact dimensions, so you can use with other models to assemble a product entirely online, meaning that you can make a product perfect the first time. Two programs you can use for this are Tinkercad for basic 3D modeling and 3D printer compatibility, or Onshape, which is a free and advanced program which has a lot of ties to First, which I will talk about later. Another skill is creating documentation. This would be a lot of writing, like explaining the reasoning for why you are making a change or why you're using a specific material. It could also be estimates for power consumption, material costs, or brainstorm drawings. This is more important for people who are already in the workplace, but is still an important skill to know. Finally, we have our technical skills. This can be using hand, power, or large-scale shop tools to actually manufacture a prototype or product. This is more important for small-scale operations such as robotics teams or startups, as you will not have access to the same tools as professionals and established corporations. This is very important to know, though, as being able to make a product with limited tools is exceptionally helpful in speeding up the process of prototyping and design. Now, we'll take a look at some programs you can join to get experience with engineering and problem solving and critical thinking. First, we have robotics programs. I mentioned earlier that Onshape has a connection with First, which is one of the largest robotics programs in the world. Each year, a board of First employees will come up with a game that each First subset will play. After they release the game, each part of First will have time to build their robots, and then they will compete against other teams in competitions. This year's FRC game, First Robotics Competition, was Reefscape, in which students had to design and build a robot to place PVC pipe onto a reef or place algae and a 9-foot-tall net on the barge, as well as many other scoring options. It forces these students to consider what they want to focus on for the competition, and it creates lasting relationships and skills for these kids. First has 3 levels, the first of which is First Lego League. This is for children in elementary school and middle school, with a focus on teaching basic engineering skills so they can develop them for the future. The second level is First Tech Challenge, which is for students 6 through 12. This is the most cost-effective for high school, as it is small scale with a small field of play. Third, the one I mentioned earlier, is the First Robotics Competition. This is exclusive to high school students grades 9 through 12. It is a large-scale game with much larger robots and pieces. It is the original program, being started in 1992. It is also the most expensive game, with many teams charging an entry fee due to the high costs. All of these programs are designed to teach kids soft skills like communication, while also teaching them hard skills to help them become future engineers. Next, we have online courses. One of the most popular courses for learning problem solving and software engineering is code.org. This is a free program designed to teach any age how to program in many different programming languages. It not only teaches programming, but also involves a lot of problem solving as well, which is one of the fundamental skills I mentioned earlier. Finally, we have different competitions. The main one I'll talk about is the M-Cubed competition, which is designed for high school juniors to use math and writing skills to make a real-world problem. This year, students were asked to analyze how heat waves can affect the electricity consumption of a city. Next, I'll go over the pros and cons of working at a startup compared to an established company. One major pro of working at a startup is that there's much less regulation and paperwork you have to do to create something. This means you can accomplish greater things at this company. Another major bonus is that you're already starting close to the top of the company from the get-go. If your startup takes off and has a major market share, you'll have lots of stock or have a high position with much less time than it takes at an established company. One major con is job security. Many startups fail, and if one you're working at fails, you'll be out of a job. A lot of startups also pay less and have you working longer hours as they need a lot of work done and they can't afford to pay high amounts. On to working at a company. When I mean established company, I mean something like Boeing or Ford, someone who has been in the market for decades and has a large market share. A couple of pros of working at an established company is that they often offer stock options, which is an extra bonus for pay. Many of these companies are also very stable and do not pose as much of a risk for job security. They have a rigid progression for roles and offer many benefits like healthcare and dental. One major con of working at these companies is that you'll be spending a lot of time doing paperwork and it won't feel like you're having much of an impact at all. Another con is that you have much smaller impact on projects, as most engineers just make small parts of a large machine instead of actually designing these machines themselves. Finally, we're going to go over the future of the industry and what I think it could look like. First, the high demand for engineering jobs. Many companies are looking to advance themselves and create new technologies to make billions of dollars. Just look at Microsoft with their Majorana 1 chip. Second, the pay. The median salary of engineering jobs is well over the average for all jobs. And with inflation, good pay means keeping up with the times. Third, the potential for growth. You can have decades of work at one company, allowing for many promotions. You also might see drastic shift in the technological landscape, allowing you to create advanced technologies. Finally, the turnover. Many companies need workers, so you can cycle jobs quickly if you don't like the one you're working at. Thank you guys for watching. I really appreciate it. Have a nice day.